Today, we will explain the Liskov Substitution Principle, the L in solid. In simple terms, if your code expects a base class or interface, any subclass should work without breaking the client code. Think of LSP as a trust contract. If a method accepts a base type, you should be able to pass any derived type, and the behavior should still make sense. The client should not need to know which exact subclass it received. The compiler only checks syntax, such as method names, parameters, and return types. LSP goes deeper. It checks whether the subclass respects the behavioral contract promised by the base abstraction. First, preconditions cannot be strengthened. A subclass cannot demand stricter input than the base class. If the base method accepts any integer, the subclass should not suddenly fail for negative values unless that was part of the original contract. Second, postconditions cannot be weakened. A subclass must deliver at least what the base class promised. If the base promises a validated non-null object, the subclass cannot return null and surprise the caller. Third, invariants must be preserved. These are truths that should always remain valid for the object. For example, a count property should never become negative because of subclass behavior. LSP also relates to type variance. A subclass should be able to accept broader input types, known as contravariants, and it may return a narrower, more specific type, known as covariance. The history constraint says a subclass must not mutate state in a way the base type would not allow. If the base class is designed to be immutable, a subclass should not introduce mutable fields. A common violation is the not implemented exception smell. Here, read-only cache implements iReadWrite repository, but cannot save. Client code trusts the interface and calls save. At runtime, the abstraction breaks its promise, and the client crashes. Another smell is type checking or downcasting. If client code uses is, as, or get type to handle subclass quirks, the abstraction is leaking. The client is no longer working with a stable contract. To fix LSP issues, lean on interface segregation and composition. Split interfaces into smaller contracts. A read-only cache should implement iReader, not iWriter. And if a class only needs some behavior from another class, prefer composition over inheritance. In code reviews, ask 3 questions. Does the subclass inherit methods it cannot fulfill? Does it add stricter validation than the parent? Does client code need is, as, or get type to work safely? If yes, you are likely seeing an LSP violation. The key takeaway is simple. LSP protects client code from surprises. A good abstraction does not just compile. It tells the truth about behavior.